Namaste everyone. We have started a new series today for NCERT Mathematics syllabus. So first we will be seeing 10th class mathematics. In our lectures we will be covering most of the basic theory that is required to solve the problems from each and every exercise. And after that we will be seeing also the problems from different government examinations, which will help you to understand the mathematical concepts in a very broad way. Every chapter will be dividing every chapter into few sections depending on the number of exercise in that chapter. So suppose chapter 1 has 4 exercises, then we will be covering chapter 1 in 4 lectures. So let's start with the 10th class NCERT Mathematics syllabus. First chapter is real numbers. In the first lecture we will be studying different types of numbers, the HCF and LCM, prime factorization method, and properties of HCM and LCM. And at the end of the lecture we will be seeing few examples which will help you to understand the concept of HCF and LCM. So what are the different types of numbers that you will encounter in this syllabus? First one is real numbers, prime numbers, rational numbers, irrational numbers, co-primes, and composite numbers. So let's start with the real number. What is a real number? Real numbers in mathematics, a real number is a value of a continuous quantity that can represent a distance along a line. So what does this mean? Any number which can be plotted on the number line. Suppose this is a number line. Here we have 0, plus 1, plus 2, minus 1, minus 2. So any positive, negative number or a rational and irrational number which can be represented on this number line is called as real number. So what are the examples of real number? Plus 2, plus 3, minus 5, 0.378, the number pi. So all these values we can plot on the number line. So these are called real numbers. So regarding these definitions, you don't have to remember these definitions word by word. You just have to understand the concept, which will help you to solve the different problems. Now let us look at the second type of number. It is a prime number. So many of you already know this concept. Prime numbers are those numbers which can be divided exactly only by itself and 1. So if you try to divide prime numbers by any other number, you won't be getting you can't divide them exactly. So what are the examples of prime numbers? 2, 3, 5, 7, 11, like that. So for 2, let us consider example 5. So for 5, there will be only 2 numbers which can divide 5 exactly. It will be number itself, that is 5 and 1. So such numbers are called as prime numbers. Now let us look at the example of rational numbers. A rational number is a number that can be expressed as the quotient or fraction p by q of 2 integers, and q should not be equal to 0. So any number which you can represent in the form of p by q where q is not equal to 0 is called as rational number. So these are just definitions. Certain numbers are defined in a certain way. So what are the examples of rational number? 1 by 2, 0.75. This can be represented as 75 divided by 100. So you can represent this in the form of fraction. So it is called as rational number. Negative values are also called as rational numbers. So next one is irrational numbers. Those numbers which cannot be represented by dividing two numbers or in the form of fraction p by q, then those numbers are called as irrational numbers. So root 2 or value of pi, these are irrational numbers. You can't represent them in the form of p by q. So those are called as irrational numbers. For root 2 or root of any prime number, you can consider that as an irrational number. Let us move to next definition. Integers. This is the most easiest definition. Integer, it is a number with no fractional values, is called as integer. So the whole numbers such as 12, 54, -4, these are called as integers. So during our syllabus we will be seeing one more concept of co-primes, and the last one is composite numbers. So let us look into the definition of co-prime. In number theory, two integers a and b are said to be relatively prime, mutually prime, or co-prime if the only positive integer that divides both of them is 1. So the co-primes have only one number as their common divisor. That will be 1 only. So take example of any prime numbers such as 17 or 23. This can be divided only by the number itself and 1. Then only you will you can divide them exactly only by itself and 1. So what is the common factor they have as their divisor? It is 1 only. You can divide 17 and 23 both by the factor 1. So these are called as co-prime numbers. Any number, for example, take 11 and let's say 31. Then these two will be the prime numbers, and they can also be called as co-primes because they have one common divisor as value 1. You can divide both of them by 1. So these two are called as co-primes. Now next definition is composite number. Composite number is a positive integer which is not prime. Or in other words, if you multiply any two numbers, let's say 2 into 3 or 5 into 4, so you will get the value as 6, 20 or 24. So these are called as composite numbers, which are formed by multiplying two numbers. These are called as composite numbers. Now our next definition will be prime factorization. What is prime factorization? Prime factorization is a number written as the product of its prime factors. Suppose take any number, let's say 12. If you represent this number in the form of product of its prime factors, then the method is called as prime factorization. We will be using this method while solving problems on the HCF and LCM. So that is why this concept is important. Prime factorization is nothing but representing any number in the form of its prime factors. Let's represent 12. So if you multiply 2 into 2 into 3, it will be 12. How do we get these numbers? There is one alternate method also. Let's say represent 12 in this form. 12. divide 12 by 2, it will be 6. Again divide 6 by 2, it will be 3. So until you get the value 1 as the remainder, you have to continue this division process. Then you can take all these factors and write them in this form. So 2 into 2 into 3 will be 12. So you can either directly write in this form, or you can obtain these prime factors in this method. This will be easier for you. Okay, so this will be all about prime factorization method. This is the important concept. While solving the HCF and LCM problems, you need to represent every number in this form. Then only you will be able to solve the problems. Okay, it is just a common division process. Divide 12 by 2, you will get 6. Divide 6 by another prime factor 2, you will get 3. Divide 3 by another prime factor 3, you will get 1. Once you get the remainder as 1, then all these prime factors should be the prime factorization method for any number that you want to represent in the form of prime factors. Now let's move to the next definition. HCF. So what is HCF? Highest common factor, also called as greatest common divisor of two or more integers which are not all 0, is the largest positive integer that divides each of the integers. So what does this mean? If you have given 2 or more than 2 numbers, and if you are told to find the HCF, then the HCF will be the largest positive integer that can divide all the given numbers. Okay, it will be a common divisor for all the given numbers. So obviously it will be smaller than all the given numbers. Let's take the example of 69 and 46. If you have been told to find the HCF of these two numbers, let's represent them in prime factorization method. For 69, you will have the prime factor as 3 and 23. For 46, you will have prime factors as 2 and 23. So let's look into the definition. Definition says common divisor for the given numbers. What is the common divisor between these two factors? 3 is not common, 2 is also not common. What we have is 23 is common. So the HCF of 69 and 46 will be 23. Like that. Now let's take a second example. HCF of 15 and 72. What are the prime factors of 15? 3 into 5. For 72, what are the prime factors? Let's say how to find these prime factors for 72. Let's divide 72. If we divide 72 by 2, it will be 36. Again divide by 2, it will be 18. Now 9. So for 9 you have to divide by 3. 3 into 3 will get the 9. Now again 3 is a prime number, so it can be divided only by itself and 1. So once you get the 1, these will be the prime factors. 2 cube into 3 square. See here, 2 into 2 into 2, these 3 values, and after that 3 into 3. So these will be the factors of 72. So HCF of 15 and 72. What is the HCF definition? Common divisor of 2 or more integers. Common divisor, 3 is common. Okay, so what is the least power of 3 between these two factors? Here we have 3 raised to 1, here we have 3 square. So what is the least value? It will be 3. 2 is not common in both the prime factors. For prime factorization of 15 and 72, only 3 is common. 5 is also not common and 2 is also not common. So what is the least power of 3? It is 3 raised to 1. So it will be 3. HCF of 15 and 72 will be 3. So let's put into words. Let's put this into the words. HCF will be product of the smallest power of each common factor in the numbers. Product of the smallest power of each common factor. So what is the common factor between these two? 3. We have to take smallest power. What is the smallest power? 3 raised to 1. Here we have 3 square, so smallest will be 3 raised to 1. So we have taken 3. So it has to be a common factor and we have to take the smallest power of that factor. Suppose you have another common number between these two factors, then you have to take the minimum power of that number and represent that in front of this in the form of multiplication. So that multiplication will give you the HCF. We will see that in our next examples. Okay. Now for now, just remember you have to take the common factor and smallest power of that common factor and put those things into multiplication form. So you will get the HCF. Similarly, our next concept is LCM. In arithmetic and number theory, the least common multiple, LCM, long form of LCM is least common multiple of two integers, is the smallest positive integer that is divisible by both given numbers. Suppose you have been given two numbers, then you have to find a number such a way that you can divide that number by both the given numbers exactly. Then that number is called as LCM. That number has to be the least value. Let's take the same example of 15 and 72. So factors of 15 will be 3 into 5. For 72, we have already obtained the prime factorization for 72. Now let's find the LCM of 15 and 72. You have to represent every prime factor in LCM. It is not like finding HCF. This is a different method for LCM. Take each and every prime factor from the prime factorization of both numbers. So let's take first 3. What is the maximum power of 3 in both these prime factors? Here we have 3 raised to 1, here we have 3 raised to 2. So in HCF we have taken as least power. Now in LCM we will take the maximum power, that is highest power. So here we have 3 raised to 1, here we have 3 square. So 3 square will be the prime factor that we will be considering. Next we have 5. 5 is not common, but in LCM we have to take each and every prime factor with its highest power. So we have taken 5. There is no other power of 5, so it will be 5 raised to 1 only. So 2 is also not common in both these prime factors. So we have taken 2 cube as what is the highest power of 2 that we will get? 2 raised to cube. If we multiply these numbers, you will get 360. So what we have done in LCM is we have considered every prime factor with its highest power. 3 with its highest power, 5 with its highest power, 2 with its highest power. 2 into 2 into 2, it will be 2 cube. So if you take this multiplication, it will be 360. So LCM of 15 and 72 will be 360. What was its HCF? It was 3 only. Why? Because we have considered it in HCF common factor with least power. So we got HCF as 3, but in LCM we consider each prime factor with its highest power. So you get the HCF as 360. So let's consider this example. So see here, for HCF value is less than both the given numbers. Observe here, 3 is less than 15, 3 is less than 72 also. But in case of LCM, the LCM is always greater than the given two numbers. 15 and 72 is less than number 360. So how will you find the LCM? Product of the greatest power of each prime factor involved in the numbers. So you have to consider each prime factor with its greatest power. But in HCF you have to consider common prime factor with its smallest power. Remember the difference. So let's see a few notes also. Rather, you can say properties. The sum or difference of a rational and an irrational number is always irrational, and the product and quotient of a non-zero rational and irrational number is also an irrational number. Apart from the numbers that we have seen previously, such as real number, prime number, integer, composite number, co-primes, apart from those numbers you have also two other type of numbers. Those are imaginary numbers and complex numbers. So this you will be learning in your subsequent standards. So you don't have to be bothered by these definitions. Just remember there are other two types of numbers, imaginary numbers and complex numbers. So after this we'll be seeing few examples on the HCF and LCM, and after that we'll see the properties of HCM and LCM. Now let's solve few examples on HCF and LCM. So our first example will be finding HCF and LCM of three numbers, 56, 72 and 120. Sorry for the interruption, friends. So let's see the HCF and LCM of these three numbers. So let's first represent 56 in the form of prime factors. So how will you do that? First you have to do this calculation on your rough paper, and once you get the final remainder as 1, then take product of these numbers and it will be your prime factorization for given number. So it will be 2 into 2 into 2 into 7. Now let's take second number, 72. We have already done for number 72. It will be, once you divide 72 by number 2, it will be 36, 18, 9, 3 into 1 equal to 3, 3 into 3, 9, 2 into 9, 18, 2 into 18, 36, 2 into 36, 72. So let's take product of these factors. You will have the prime factorization for number 17. So it will be 2 cube into 3 square. 2 into 2 into 2, it will be 2 cube into 3 into 3. 3 into 3. So similarly for 120 you can do that calculation on your own. So prime factorization for 120 will be 2 into 2 into 2 into 3 into 5. Okay, let's do it for 120 also. It will be 2 divided 120 by 2, it will be 60. 60 by 2, it will be 30. 30 by 2, it will be 15. So for 15 you will have the prime factor as 3. You can't divide 15 by 2, you have to take 3. 15 by 3, you will have 5. So for 5 it is a prime number, so 5 by 5 you will have 1. So 2 into 2 into 2, you have represented that here, into 3 into 5. So let's find the HCF of 56, 72 and 120. What is the, now for finding HCF you have to take the common factor and the least power. Okay, so 2 is common in every factorization. See, you have 2 in all three factorizations. So what is the least power of 2? It is same in every factorization, so it will be 2 cube. 7 is also not common. 3 is not common because 7 you don't have 7 in. So 2 is common, so we have taken 2 cube. Now consider 7. 7 is not there in these two factors. 3 is also not common. You don't have 3 in this factorization. Factorization of 56 is doesn't have number 3 and 5. So only common thing will be 2 cube. So what you will have as HCF is 2 cube, which will be 8. So HCF of these three numbers is 8. Similarly, let's see the LCM of 56, 72 and 120. So for LCM we'll be considering every prime factor, not the common one. For LCM we have to consider every prime factor with its highest power. So let's take first 2. What is the highest power in all these three factorizations? It will be 2 cube. Second prime factor is 7. What is the highest power of 7 in all these three numbers? It will be 7 raised to 1 only. Third number will be, we have already considered 2, now consider 3. What is the highest power of 3 between these two factorizations? Here we have 3 square, here we have 3 raised to 1. So it will be 3 square. Now consider last number 5. What is the highest power of 5 that we have in all these three numbers? It will be 5 raised to 1 only. So product of these four numbers will be the LCM. What will be the product? It will be 2520. Now let's see. For HCF we have considered common factor with least power. It will be 2 cube 8. For LCM we have considered every prime factor with its highest power. Okay, now here look at these values. 8 is smaller than each and every number that you have been given, and the LCM value is greater than every number that we have been given. Okay, this will be the property of HCM and LCM. LCM is always greater than the given numbers and HCF is always less than the given numbers. This is the property. Let's take second example. So you have been given these three numbers. So for that you have to find the HCF and LCM. So for this I will be giving you the sample calculation only for the one number. Let's take for prime factorization of 1275. So you can divide 1275 by number, let's say 3. You can also start by 5. You will get the same answer. The sequence doesn't matter. So let's take 3 as its divisor. So what you will get is 425 as your answer, then you can divide 425 by number 5, because at the end you have 5, so it will be 85. Again you can divide 85 by 5, you will get answer as 17. 17 is a prime number, so you can divide it only by itself and 1. So once you get the 1, you will have the prime factors of 1275 as 3 into 5 into 5 into 17. Similarly for 552, you can do it by using this method. It will be the easiest one for you. So for 552, you will get prime factors as, once you practice lot of examples, then you can represent prime factorization directly in this form. You don't have to do this calculation. You will get used to it. And the third one that you have been given is 175. What will be the prime factors? It will be 5 into 5 into 7. So let's find the HCF of these numbers. 175, 552 and 1275. So for HCF you have to find the common number, common prime factor with its least power. So let's consider 3. You have 3 in these two prime factorizations, but there is no number 3 in this prime factors of 175. Similarly for 5, you don't have 5 in prime factors of 552. Similarly for 17, you don't have 17 in these two values. Okay, so there is no common prime factor between these three prime factorizations. So what will be the HCF? It will be 1. You can divide all these three numbers by value 1. So 1 will be the HCF. This is one of the unique case where you don't have the common prime factor. So what will be the number that can divide these three numbers? It will be 1, because the definition of HCF is common number that can be, the highest common factor definition is number largest positive integer that divides each of the integer. So we have to find a number which can divide these three numbers. So there is no common prime factor here, so we can't find that. So what will be the obvious HCF? It will be 1. You can divide any number by value 1. So HCF of all these three numbers will be 1. Now consider LCM of these three numbers. Least common multiple, it will be, let's find it out, 175, 552, 1275. So for LCM, you have to consider each and every prime factor with its highest power. So let's take all these numbers. I will represent this in here because you don't have space there. So let's consider the each and every prime factor. Let's start with the number 5. So for 5, the highest power of 5 you have is 5 square. 5 into 5, 5 square. Let's consider now 7. Highest power of 7 is 1 only. 7 into, let's consider 2. What is the highest power of 2? 2 into 2 into 2, 2 cube. Now consider number 3. 3 raised to 1 only. So it will be 3. The remaining 2 will be 23 and 17. We have considered every number. We have considered 3, 3 raised to 1. We have considered 5, 5 square, 17, 2 cube. You have already considered 2 cube here. you have considered 3 already from here, and number 23 also. So we have considered every prime factor with its highest power. So if you take this multiplication, the answer you will get is 16,42,200 will be the least number that can be divided by all these 3 numbers. It is called as LCM. Okay, so similarly, let's take last example on this method. LCM and find the LCM of 18 and 84. Let's just find LCM and HCF also. Okay, what are the prime factors of 18? 18 is the small number, so you can write the prime factors directly. 2 into 3 into 3. 2 into 3 6, 6 into 3 18. For 84 you have prime factors as 2 into 2 into 3 into 7. You can use this method to find every prime factorization for any number. Okay, I have written directly for 18 and 84. So what will be HCF of 18 and 84? You have to consider the common prime factor with its least power. What is the common prime factors in these two numbers? 2 and 3. 7 is not common. So what is the least power of 2? It will be 2 raised to 1. What is the least power of 3? 3 raised to 1. So product will be 6. So HCF will be 6. Now find the LCM. For LCM you have to consider every prime factor with its highest power. Every prime factor with its highest power. For HCF you have to consider smallest power. For LCM you have to consider highest power. It is not like that if it is LCM you have to consider highest power only for each and every prime factor. So let's consider 2. It will be highest power will be 2. For 3 highest power we have 3 into 3, 3 square. For 7 it will be 7 raised to 1. So product will be 252. LCM of 18 and 84 will be 252. Solve few examples, then you will understand this method easily. Just remember that you have to do this calculation on a rough paper, not on your answer sheet. Okay, on answer sheet you have to write directly the prime factorization. For HCF you have to consider the common prime factor with its least power. For LCM it will be every prime factor with its highest power. That is the important thing that you have to remember. Let's look into the few properties of HCF and LCM. See, these properties will help you to solve the examples from competitive examinations, because in those examinations you have to solve the problem within 1 or 2 minutes. So if you remember the properties, it will be easier for you to get the answer within that short duration. It will help you to score higher marks. So what will be the first property of HCF and LCM? HCF of given numbers is not greater than any of the numbers that we have already seen. HCF is always less than the given numbers. So what is similarly what will be the property of LCM? LCM will not be less than any of the given numbers. So LCM value will be always greater than given numbers. HCF of two co-prime numbers is 1. So what is the prime number? You can divide prime numbers only by itself and the value 1. So for co-primes there is only one common factor which can divide both the given numbers, which is 1. So you can divide co-prime numbers by 1. So HCF will be 1. The highest common factor will be 1 only for co-prime numbers. So if you have been given a pair of co-prime numbers, then you can directly find the HCF as 1 only. Now let's say LCM. LCM of two or more co-prime numbers is equal to their product. Because for co-prime numbers there won't be any number other than the for co-primes there won't be any prime factorization because those numbers can be divided only by itself and number 1. So you can take directly the product of those numbers to find the LCM. Next property, if you have been given a number, say x, is a factor of another number, say y, then HCF of x and y is x and their LCM is y. Why this is so? Because suppose prime factorization of x will be x only. For y you will have the x as the one of the number as prime factor. So what will be the common number? X, and least power of x will be x only. So you will have HCF as x, and LCM will be you have to consider every prime factor with its highest power. So LCM will be, sorry for the interruption friends, so let's consider this property one more time. If a number say x is a factor of another number say y, then the HCF is x and y, x and y is x itself, and their LCM will be y. So if x is a factor of y, then HCF will be x and LCM will be the other number, that will be y. While solving the examples you will understand this property in a better way. Now next property will be the HCF of given numbers is always a factor of their LCM. Let's consider this example 3 and 15. So what this property says is HCF of given numbers, that will be 3, is always a factor of their LCM. See, factors of LCM are 3 and 15. So HCF is a factor of 3 is a factor of LCM. Now consider next property. The product of the HCF and LCM of two numbers is equal to the product of the given numbers, that is HCF into LCM equal to first number into second number. So what you have to remember in this property is this property is applicable to only two numbers. If numbers are more than 2, then this property won't work. So if the given numbers are 2, then the product of their HCF and LCM will be product of those two numbers. Let's consider this example once again, 3 and 15. So consider their product, HCF into LCM equal to A into B. HCF is 3, LCM is 45. So what will be the answer here? So I have made some corrections here. Okay, so product of HCF into LCM, HCF is 3, LCM is 15. So if you consider A into B, that is these two numbers, it will be also equal. So this property will be verified. HCF into LCM equal to A into B, A into B. Okay. But this property, if numbers are more than 2, that consider, let's say numbers are 3, then this property won't work. In that case we have different formula. If given numbers are 3, then HCF of those 3 numbers into LCM of those 3 numbers is not equal to the product of those 2 numbers. If numbers are 2, then this property will work. If numbers are 3, then it won't be equal to their product. So in that case, how will you find the HCF? HCF of those 3 numbers will be product of those 3 numbers into their LCM divided by LCM of first 2 numbers, LCM of second 2 numbers, and LCM of first and last number. So in that way you can find the HCF. Similarly, for LCM of PQR equal to P into Q into R into HCF of PQR divided by product of HCF of PQ into HCF of QR into HCF of PR. Okay, this property will help you to find the HCF and LCM of 3 numbers. This is an easy formula. You can if you read it 2-3 times, then you can easily remember it. If you have to find HCF, you have to use LCM terms. If you have to find LCM, you have to use HCF terms. Okay, now let's see the last property. If you have to find the HCF and LCM of fractions, let's say LCM of a fractions, if you have 2 fractions, let's say 2 by 5 plus 3 by 5, then how will you find the LCM? You have to find the LCM of numerators, then you have to find the HCM of denominators, and their division will be the LCM of fractions. So LCM of fractions will be LCM of numerators divided by HCF of denominators. HCF of fractions will be HCF of numerators divided by LCM of denominators. So while finding LCM, you have to find the LCM of numerator and HCF of denominators, and their division will be the LCM of fractions. So this will be all about the properties of HCF and LCM. Now let's see few examples from textbook as well as from competitive examinations, central government competitive examinations, which you will be attempting after your 12th or after your degree examinations. So in those examinations there will be some additional concepts which will be required to solve those problems. So if we have taken this lecture for about almost 40 to 50 minutes. So once you clear your basics, then it will be easier for you to solve the problems. Now let's consider, we have spent enough time on the concept, so it will be easier for you to solve the problems. In our subsequent lectures we will be only focusing on problems, so those lectures won't be of much longer duration. Those will be short lectures, about 15 to 20 minutes. So let's see some problems on HCF and LCM. So once again we will revise the HCF and LCM concept by solving this simple example. Already we have solved few examples like this one. Already we have solved 3 examples. So factors of HCF and LCM of 6, 72 and 120. So factors of 6 will be 2 into 3. Factors of 72 will be, you can find those factors by considering the method that we have already seen. So factors of 72, how will you find those factors? 2 into 2 into 2 into 3 into 3. So for 120 you have to use the same method to find the factors. This one 120, you have 60, 30, 15, So factors of 120 will be 2 into 2 into 2 into 3 into 5. Okay, so HCF will be, you have to take common factor with least power. So HCF that we will get is 2 into 3 equal to 6. So LCM will be, LCM of 6, 72 and 120 will be, you have to find it by considering each prime factor with its highest power. So it will come around 360, it will come exactly 360. So you can find that by, you can take this as assignment and write down the solution in detail. So we have revised the HCF and LCM concept in this example. This one was easiest one. Now let's consider second example, which will be little more, you can't say difficult, but it will require some property of HCF and LCM. So in this example, you have been given LCM and HCF of two numbers and one of the number is given. So LCM of two numbers is 864, their HCF is 144. If one of the number is 288, the other number you have to find. So what we already have seen, one property of HCF and LCM, we have HCF of A into B, A and HCF of A and B into LCM of A and B equal to product of those two numbers. So you have been given HCF and LCM, 864 into 144 equal to, one of the number given is A is 288 into B. So you can find B easily from this product. So what will you get? It will be around, it will be exactly 432. You have to divide this product by 288. So this is the important property that we have used in this example. Okay, so that's why properties of HCF and LCM, this was the example from Staff Selection Commission. I think it was for degree students. Those who have completed degree, those can attempt these examinations. So for competitive examinations, these kind of small tricks will help you to find the answer as quickly as possible. So we have used this property and found the second number as 432. This one was easiest one example. Now consider third example. We'll be seeing around 7 examples for HCF and LCM. So this one is third one. HCF and LCM of two numbers are 13 and 455 respectively. If one of the number lies between 75 and 125, then that number is. So there is some twist in this example. Instead of giving one of the number, they have given the range in which one of the number falls. So again we have to use same property. HCF, let's say A and B into LCM of A and B equal to A into B. So we have, let's consider HCF is 13. Okay, so one of the property of HCF and LCM is HCF is always the factor of LCM. Already we have seen that. You can refer the previous example. So by considering that, we can say that there will be, A will be 13 into some factor and second number B will be 13 into some factor. So these will be the two numbers. How you can find this one? Let's say HCF. HCF is 13. So it will be easier for you to understand. Let's say HCF is always a factor of LCM. So first number we will consider is 13 into x. 13 will be the HCF. We'll discard this solution. It will be easier for you to understand if we use only one variable. Let's say HCF into LCM will be product of two numbers. Let's say let's say 13x into 13y. Why we have used here 13? Because HCF is always a factor of the LCM. How you can say that? Let's see the previous example that we have seen. Here you can see that HCF, which is 3, is a factor of LCM. You can see that here. So if you consider first number, just you have to put here some factor. Let's say it will be, here it is 1. So first number will be 3. 3 into 1, 3. So here 3 into some factor, it will give you the second number, 15. So 3 into, we have here second factor as 5. Can you understand? Instead of, we have taken 13x and 13y. Why? Because HCF into some factor will be the first number. HCF into some factor will be the second number. So here some factor is 1. 3 into 1, 1. So while for solving the LCM, 3 into 5, you have 15. So what we have to do is we have to find the value of x and y for which the given conditions in the problem number 3 will be satisfied. So let's again consider it. 13 into 455 equal to 13x into 13y. Okay, so x into y will be 13 into 455 divided by 13. So x into y will be, this will go away. So x into y will be 455 divided by 13. So what will be the answer for this problem? So you have 455 by 13 will be 35. So product of these two numbers will be 35. So what will be the possible values of x and y? Possible values of x and y will be 35, 1. Suppose x is 35, then y will be 1, or 7, 5. If x is 7, then y will be 5. These are the only two possible factors of 35. If we do the prime factorization of 35, it will be 7 into 5. So these are the two sets which will give you the answer for the given problem. So what are our values? 13x into 13y. So 13x, 13y will have two possible solutions depending on these two sets. 35, 1. So if you consider this set, then 13x, 13y will give you the values as, you can multiply 35 by 13. It will give you the answer as 455, 13. And the second set will be 7, 5. So if you multiply 7 and 5 by 13, it will give you this. If you can consider 13x, x will be 7. 13 into 7, it will give you 91, 13 into y. What is y? 5. 13 into 5 will be 65. See, so what is the one of the condition that you have been given? One number lies between 75 and 125. Which is the number which lies between 75 and 125? It will be 91. So our answer will be, those two numbers will be 91, 65. This will be our answer. Okay, so what is important here is you should understand this step. After this step, everything is easy. So how does this step you can get? HCF will be always the factor of LCM. HCF is factor of LCM. So this is the main concept that you have to understand. So HCF into some factor will be the first number, HCF into some factor will be the second number. If you solve this problem on your own by revising the properties that we have studied earlier, then you will understand this step in a better way. Once you understand this step, everything will be easier for you. Please do revise it. Now let's consider next example. Example 4. The maximum number of students among whom 1001 pens and 910 pencils can be distributed in such a way that each student gets same number of pens and same number of pencils. So you have to distribute same number of pens and pencil to a group of students. So here what is important is what should be calculated, HCF or LCM. If we calculate LCM, it will be more than these two numbers. Obviously, that is one of the property of LCM. So if the number of students are more than these two numbers, then you can't distribute these objects into those students. So obviously what you have to find here is HCF of A and B. So you have to factorize 1001, you have to factorize 910, and their HCF will be the number of students among which you can distribute pens and pencils equally. So you can find this HCF by using the method that you have already studied. Factors of 1001 will be 11 into 91. Factors of 910 will be 2 into 5 into 91. So HCF is common factor with least power, that will be 91. 91 number of students can be distributed with 1001 pens and 910 pencils. This will be your answer. So important thing here in these kind of problems is what to find, HCF or LCM. That you have to figure out. Once you figure out that, then you can find the answer easily. Then it is just a normal process. So in this example we have found the HCF, because LCM will be the number more than the given number of objects. So obviously we can't use LCM. It has to be HCF. Okay. Now let's consider second example. Next example. The least number which when divided by 4, 6, 8, 12 or 16 leaves a remainder of 2 in each case is. So you have to find a number, least number, which can be divided by all these given 5 numbers, and that number after division should leave a remainder of 2. So obviously you have to find the LCM, because in LCM only we find the least number to which the given numbers can divide exactly. So let's find the number of let's find the LCM of given numbers. So you have to factorize the 4. It will be 2 into 2. For 6 it will be 2 into 3. 8 it will be 2 into 2 into 2. 12 and 16. So LCM of these given numbers is 2 raised to 4 into 3, it will be 48. So you can divide 48 by these numbers. It will give you the exact, you can divide 48 exactly by these numbers. But what is our condition is the number should leave a remainder of 2. So what you can do is add 42. Answer will be 42 plus 2 equal to 50. So if you divide 50 by these numbers, any of this number, then it will give a remainder of 2. If you divide 50 by 8, it will give you the remainder as 2. If you divide 50 by 16, it will give you remainder as 2. This is the condition we have been given. So what you have to find in this, what is the important thing in this problem is you have to find the LCM and you have to add 2 to find the number which can leave the remainder as 2, because for LCM you will get the exact division. For LCM can be divided exactly by given numbers, but our condition is the remainder should be 2. So each of this number can divide 48 exactly, so it won't give you any remainder. So you have to add 2 to get the exact answer. It will be 50. Now let's consider the second example. One more to go and we'll be done with this lecture. This lecture will be completed. So in this example, 4 bells ring at intervals of 4, 6, 8 and 14 seconds. They start ringing simultaneously at 12 o'clock. At what time will they again ring simultaneously? So these are the kind of problems you will be getting in competitive exams. So what is important is you have to understand the wording. You have to find out what needs to be calculated, HCF or LCM, and then after that it will be easier for you to find the solution. So let's now consider at what time after 12 o'clock the bells will ring at the same time. So obviously the time has to be more than the given intervals. So you have to find the LCM. What is important in this case is you need to know that you have to find the LCM. So LCM of 4, 6, 8 and 14 will be 168. You can do this calculation on your own. It is just a simple calculation. 168 seconds. So it will give you 2 minutes and 48 seconds. So after 12 o'clock, two minutes and 48 seconds, the bells will ring again at the same time. The 4 bells will ring again at the same time. So you have to add this number into the 12 o'clock. After 12 o'clock, 2 minutes and 48 seconds, the 4 bells will ring at the same time after 12 o'clock. So what is important in this example is you have to find the LCM. Once you find Once you understand which value needs to be calculated, then it will be a matter of 2 to 3 steps. So these are the kind of tricks you have to understand in competitive examinations. Let's consider our last example. Find the greatest number of 5 digits which, when divided by 3, 5, 8 and 12, leaves 2 as remainder. So number which can be divided. So obviously you have to find the LCM. So again, here condition here is the number has to be of 5 digits and it should leave a remainder as 2. So let's just find the LCM of 3, 5, 8 and 12. So what will be its LCM? LCM will be 120. So what is the greatest number of 5 digits which can be divided by these 4 numbers exactly? So this is the least number which can be divided by these 4 numbers, which will give you the remainder as 0, and you can divide this number exactly by these 4 numbers. So what will be the 5 digit number that can be divided by these 4 numbers? So let's consider the greatest 5 digit number. It will be 99,999 divided by 120. So it will give you as the value will be 99,960. So this will be the answer, plus remainder will be, let's write this in this format. Divide 99,999 by 120. It will give you 833 as the quotient. 99,960, and the remainder will be, what is the remainder you will be getting? It will be 39. So this is the number 99,960 which can be divided exactly by these 4 numbers. So what is our condition is 5 digit number. This is a 5 digit number, but it should leave a 2 as remainder. So you have to add 2 in this value, plus 2. So our answer will be 99,962. This number when divided by any of these numbers will give you the remainder as 2. This is a 5 digit largest number which will give you the remainder 2 when divided by any of these numbers. So important things in this equation is, in this problem is, you have to find the LCM. So this is the least number which can be divided by these 4 numbers. This is the least number. So what is the highest number of 5 digits which can be divided by these numbers? You have to divide the largest number of 5 digits, that is 99,999 by 120. So this will be the 5 digit number which can be divided exactly by these 4 numbers. So we have fulfilled the first condition, that is 5 digit number. This is the 5 digit number. Now the second condition is it should leave 2 as remainder. So you have to add 2 in this value. It will be 99,962. So there are 3 concepts involved. You have to find LCM. You have to divide the highest 5 digit number by the LCM. This is the second concept. Now you found the largest 5 digit number which can be divided exactly. And third concept is we have to add 2 in this number so that this condition will be fulfilled. We will get 2 as remainder. Okay, we have seen 7 problems from competitive examinations which involve different kind of concepts. So we have covered almost every basic related to HCF and LCM, their properties, different types of numbers, basic examples from competitive examinations as well, government competitive examinations. So this is kind of a around 1 hour lecture, but our subsequent lectures will be of shorter durations. If you have any suggestions regarding these lectures, you can put those suggestions in comment section. We will add those suggestions in our subsequent lectures. It will help you understand the subject as well, and it will help us also to improve more, to deliver the quality content. If you like our videos, then please do subscribe our channel. We'll be covering basic concepts related to NCERT Mathematics 10th class, 11th and 12th. Plus we'll be covering the competitive examination problems as well. And we'll be solving adequate number of examples which will help you to understand the concepts in a better way. So in our next lecture, we'll be solving the Euclid's division lemma and examples on those theorem. So this will be all about this lecture. See you in the next lecture.